If you were at the New South Wales first year in maths meeting in December, then the first, what I'm going to go through will look quite familiar. I gave a talk at that meeting about maple use in our exams, but this talk is going to be more include details of the logistics of how we run the exams, and also some ways we want to sort of perhaps tidy things up and improve them in the future. So okay, so currently the current state of things at UNSW in first year maths and stats is that basically all our exams and tests are done in computer labs, invigilated. And here is a picture of that. That was probably taken quite recently, was it? Or was that a historical one?
No.
Today, right? Okay, so this is absolutely up to date. Okay, so I guess the title suggests there's going to be 3 sections, and it's large scale. Well, I'm going to talk a little bit about the last thing here: software provided, large scale. Well, you'll just hear some big numbers, and invigilated, and we'll talk about how that works. And I guess this really fits with the theme of the conference, because it is something about what maths and stats students of the future need, and some people may agree or disagree with what we say anyway. But let's have everyone so far. No? What's going on? Right. Okay. So a little bit of history. At UNSW, long before I was here, Maple was in existence, and it's been in the first year course for a very long time, more than 30 years, I think. And then all of that time since then, there's been a sort of philosophy that actually it's an important part of learning mathematics is actually learning to use some sophisticated mathematical software. But for a lot of that time, it was very much a little side thing that the students didn't, really get into. Some of them did, a lot of them just hated it. What is the point of this? But we persisted anyway, so we had a sort of thing we called the Matlab lab test way back then, where the students all went to the lab and solved problems that were you could only do with Maple. I mean, basically, we just gave them like an integral. We didn't have any technique to do by hand, and asked them for a numerical approximation, things like that. They just had to be able to use this software to do things which were connected to the course, but they were designed to be things you couldn't do by hand, but it was sort of like a side thing. I guess some students appreciated it, but a lot didn't. The exams also had some Maple in. So here's an example before COVID. I don't know if you noticed that COVID changed a lot of things. But before COVID, we used to have Maple in the exam, but this was exams that were done on with pen and paper over at Randwick Waste course, and marked by hand. And so the way Maple was in the exam was we provided some sort of fake Maple session that you could have a look at and then interpret to answer some questions about it. And so the idea there was, I guess even back then, the idea was we could present a question where the students weren't burdened with some calculation. They couldn't make a mistake in the calculation, but they had to sort of like interpret something that a computer would show them. So we've always had that in the exams for a very long time. And here's a few other examples. This is one actually just 2019, I think, just before COVID, where the calculations are done. This question, I was really pleased. I wrote this question. I loved it, the way it was all set out, and it's basically a high school question. I mean, it's just maximizing some function by calculus, right? The students were terrible at this, and they mostly just ignored that. This basic almost has the answer. There's just a couple of extra little calculations you need to do to get the answer. But they mostly ignored it. And if you looked at the student scripts, they were all just working it out by scratch from hand. They even did these differentiations. It's like they just didn't look at. They sort of kept away from it. But it's typical things like this. Here's a matrix. Here's the determinant. So we didn't You don't have to calculate that determinant, although sometimes you would ask a student to calculate the determinant. Here you didn't, but you had to know what it meant, and so on. Another typical one, all the row operations are done for you, Gaussian elimination. It's done the row operations for you, and you have to interpret the result. So the philosophy was always essentially trying to show that the Maple is useful and save the students some calculation, boring stuff. And again, when you looked at the way the students did this question, many of them just sort of like pretended they didn't see that and did the row operations themselves. Yeah, anyway. I put this one in here because I like this question as well. It's all my favorite questions I've ever written. I haven't had a good idea other than these ones. But here, this question was in the higher exam, and from that graph you can determine whether you can determine that sort of the even ones are increasing, the odd ones are decreasing, and things like that. But anyway, that was before COVID. Then so pre-COVID, we had Maple sessions showing some working that already done. Students mostly ignored it and redid it by hand. Around just before COVID as well, we introduced what we called, at the time we called them online tutorials, but that name was changed. It's now weekly Mobius lessons. And we changed the name partly because during COVID, suddenly there were online tutorials, which meant something different, and everyone was confused. But the idea was, at the time this was introduced, well, the original idea was just to make some learning resources which were a bit richer, like it have embedded videos, embedded pictures, things like that, and interactive. You could check your answer as you go. At the same time, there was some sort of, shall we say, budget emergency that meant that the faculty wanted us to reduce the number of tutorials we were teaching, and so we actually just replaced one of our face-to-face classes with the online weekly stuff. But I think it was quite a good move because the students actually really did engage with this, and they do. They still do. They really do work through all of these problems, and they can check their answers as we go. Yesterday there was talk about this kind of thing, where there was a sort of should we let the students do the quiz and then at the end they can check it and have another go looking at the results. And I think everybody here has been through something similar and decided that it's much better to just let the students check their answers as they go. It's much more satisfying for the students. It's more immediate. They really like it. So, but another important thing about this is it's, Maple TA, now Mobius, uses Maple syntax. And so it sort of had a synergy with the teaching of Maple. They would enter answers in Maple syntax. And, okay, so the attitude to Maple improved considerably when we introduced these weekly stuff because they were using it regularly, and they could check. There's buttons to check whether their answer is right. Meant that they got used to using the right syntax, and they could check the syntax as they go, and it became much less of a problem. So here's one of the lab tests. During the term, we have two tests, so lab test 1 and lab test 2. In our big courses, lab test 1, we don't allow the use of Maple. That's still pen and paper. During COVID, we did let them use Maple, but now we don't. When it was first designed, it was designed to be without Maple. Lab test 2, we let them use Maple. And here's a question which still Maple is not required, but may be helpful to help you figure it out. And here's another question where Maple is definitely required because we don't teach the students how you might solve equations like that. Okay, so the students get quite used to using Maple. During the pandemic, this is a typical exam session during the pandemic. The students didn't realise we were there watching them, but but we were. It was unsupervised. The university decided. Different universities took different decisions on this. UNSW decided no invigilation, and so everything was sort of open book, open internet, open everything. Although we did say some things were not allowed, like you must do the work yourself, and you're not allowed to just pay someone to do it. Not allowed to post your questions on check. It was open book, unsupervised. We knew the students would collaborate. We told them that was something we said they couldn't do. We allowed quite a few things and said no to some other things, but of course the students, made their own choices. So we designed a lot of we redesigned our exam questions essentially to be much more focused on this. I mean, Stuart was saying the same sort of thing, much more focused on understanding of the maths and less on procedural, calculation of things, because you can just ask from the math. So we created a lot of exam questions which were not like this. This is not the sort of exam question we would have. After the pandemic, we had a huge resource of these questions that have been designed during the pandemic with the idea in mind that the students had access to software, online calculators, and things like that. Here's an example. This question here, I would defy you to do it using software. I mean, you could. It probably, and it wouldn't be a bad thing to do, you could pick some particular functions G and plot them and look at them and try to, you could use aids to try and help you. But really you need to understand the important thing here about this is really the symmetry of this distribution. Once you've figured that out, then other things follow. So lots of questions like this. Here's another one. Mental models, that's a term I learned from Merritt, and I've been using it ever since, probably wrongly, but so here this question again, you couldn't really Google how to do this. We're given this expression here and some cross sections. What can you say about those values? And here's another one. It's the ones about the Riemann sum. Again, you can't really Google how to do this, but it's not that hard to do if you know what sum is. Okay, so after the pandemic, well, me and a number of other people were quite traumatized by the level of the number of academic integrity cases that we had dealt with, it was quite clear. To me and to others, that we really would be much better off if students came back to do their exams in form. But the university wasn't necessarily on board with that idea, and we used to use the rapid race course for our exams. It's a big area, and they weren't going to do that anymore. There's different thoughts about this, but essentially the university wanted. And in some ways, a programmatic assessment is a term that gets bandied around, and certainly a student to get a degree has to take a number of sequence of courses, and they you can't get if you have to do an exam in every third course, you're not going to get through your degree without having to do any exams. So I can understand that point of view, but maybe maths is a little bit different, perhaps on your point of view. But we successfully argued that we wanted to invigilate our first year exams, but we didn't have Adele. I can see Adele was one of the most argumentative, but we weren't going to get the central exams unit to invigilate our course with 2,000 students in it. So what did we do? Well, we had this large resource of these exam questions, which were much more focused on understanding, but they have been written with the assumption in mind that certainly Maple was available and other resources too. How could we sort of perhaps use this to have run invigilated exams? Well, we've got some computer labs down in the basement of this building with about 190 seats. They've been used in the past for those Maple lab tests. They've been used just before the pandemic. We started using them for lab test 1 and lab test 2. And we could use them again. But if you've got 2,000 students, 2,000 is greater than 190. So there's no way to no matter what you try and do, you cannot squeeze the whole cohort in there at once. So how could we deal with this? Well, we decided to run exams, using Mobius, using this question bank we already had, plus some newly developed questions, and run them in batches. So we now have, well, we're pretty efficient, I think. I think we probably do get close to having that lab pretty full. And so say in term one, we're going to hear more about that in detail, I think, from Dominic and Kevin. We had like days and days and days of exam sessions for our big course. Well, what do we do about students, communicating between themselves about what's in the exam? Well, we use this big exam bank, and we tell the students you're going to get some questions from this exam bank, and it's a very big collection of questions. So there are other advantages. It's just that the last talk was about grade scope and marking being very efficient. With Mobius, you can essentially do something similar in the sense that the questions are diced up into small things that one person can focus on a whole lot of things, and you can design the grading algorithm how you like and change it later and regrade and that kind of thing. We don't get quite the same level of data on. I quite like that level of data on what the common mistakes were. We only get that anecdotally from the markers. And we don't have any handwriting. We just have students typing mathematics. So that changes the way we ask questions as well. Okay, so so we're in the lab. The students are at a computer with questions designed such that, having in mind that students would have access to software and there's software on the computer, why would we block them? Why would we say you can't use the software? Questions are designed to be done with software, and software's on the computer. So we now have all of our first year exams, not always Maple. Stats course has R available. Mathematica is also available. We don't tell students how to use that, and they mostly don't. I have seen students using Python in the exam, and Matlab's there. Matlab is available. Some courses teach Matlab explicitly, but it's available to all as well. So how is this related to the theme of the meeting? What do students need? Well, I think that I feel like we've now caught up to about 20 or 30 years ago by allowing students to use these tools that we've all been using, and everybody in the workplace has been using for many years. So we must have. We're sort of forced to run exams on our labs. We don't really have another good way to process such a large group of students. We've got a large bank of questions designed to be done with software. We've got all the software on the lab computers. No one in the workplace out there actually does any work, does hand calculations with maths anymore. So then there's the arguments about how much hand calculation you need to understand something. One thing I learned in this meeting, actually, I was talking to Don yesterday about some nursing course, and they were getting students to take a 1 litre thing, maybe a carton or a cylinder or something like that, and divide it up, and then extracting 1 milliliter out of that with a syringe. I mean, I think that's a really good metaphor for the idea that perhaps there are other ways to gain mathematical understanding, mathematical sense that isn't something that we traditionally see in the class, in the mathematics classroom. So I think we need to be a little bit, think a little bit carefully about how much of the hand calculation is required and what other things could be done. I mean, there's a lot of software, there's a lot of visualization that we can do of mathematics, which probably, we don't really do enough of that, I think, to make students understand what mathematics is. So anyway, I think it just, we let the students use software. There are other ways to perhaps compensate for lack of calculation. Balance, you can come and strangle me afterwards if you don't agree, but that's so anyway, logical conclusion, we should allow software use in our exams, and I've got a quote here from a student. That's good. Maple used to be the most complained about aspect of our first year courses. Now it's one of the things the students like. Here's the proof. There was one statement by I love the use of Maple and other software to enhance our learning. Don't waste time with tedious things. students largely embrace making first year courses now. This does have effects in their second year courses, and this is something that that needs to be considered. But I won't spoil my story with that right now. Anyway, I think I'll hand over to someone who might just Kevin or Dominic, or is it going to be a double act? Double act. Okay, so that's the transition.
The transition. Yeah. Right. Thank you, Jonathan. Yeah. So we are going to talk mostly about the logistics of these lab tests and final exams sessions that happen downstairs. Basically, I mentioned we're going to allow computers. We're going to allow use of softwares, and well, if we are embracing it, we should come up with some sort of like good plan to teach. So yeah, so I'm Kevin, and
Dominic
is Dominic. So we basically we are both managing the basically the coordinating the lab tests and final exams. This is happening for first year courses, maybe some of the second year courses, and maybe beyond.
Speak up.
Oh, speak out.
Use your big voice.
Okay, yeah, sorry.
Actually, if you stand here a little bit more centrally, I think.
Right. Yeah, okay. Yeah, so further to my right. Yeah. Okay, this is good. Stop moving. Okay. Right. Yes, this is better. That's better. Can you go online? Okay, we just like let me know. Yeah. Yeah. Okay. So yeah, so maybe just in terms of logistics, because we basically in general at any given term, we will usually host this 6 to 8 first year courses, and then maybe 3 to 4 second year courses, maybe some higher courses. Okay, so maybe there's demand basically. And well, in last term, 2024, term 1, this translates to, well, almost 500 lab test sessions. So lab test 1, lab test 2 combined during our teaching weeks. So yes, we have we have 10 teaching weeks, week 4, week up to week 10, exception of week 6, and about 50 final exam sessions happening during the exam weeks. Okay, so
thank you. So like the idea here is that, of course, if we're going to be running all of these tests, then we're going to need a bunch of people who are actually going to manage all of this. We have a roster of about 50 invigilators this term who are currently hard at work running our lab tests. We're currently in week 5, so they're doing lab test 1 down the labs today. So just in terms of like how we do this, like the turnaround is relatively tight between terms because I'm sure people who are working at UNSW know that term 1 doesn't really end at the start of term 2. In fact, we had a one student taking a term 1 test
as we speak,
actually, it's 2 o'clock. Term 1 technically isn't over yet, and we're in week 5 of term 2 already. So we try to do our best. We allocate invigilators roughly around week 2 to 3 for the lab test sessions, and roughly around about the same for the final exams. We do so around about week 10, week 11. And in terms of actually getting them trained up, we usually pair up new invigilators with some of our more experienced invigilators just in efficiency. This also means that we need to have someone on staff who is very familiar with all of the systems to handle any emergencies as they arise. We're basically constantly on Teams. So it's actually a little bit nerve-wracking because Kevin and I are the only people on campus at the moment who are able to handle, and Jonathan as well, and Yudi is on a plane. But hopefully no emergencies happen during this.
Check Teams now.
Yeah. Okay, so we've been working on some improvements. So over the pandemic, basically we have this because we are allowing softwares now, and maybe there are some demands among which software we want to use, which software we want to maybe not use, maybe there's some preference. There is some also need to block internet. That's definitely the case with most of the courses, first year courses, second year courses, but we can actually customize this. So we've been working with the school's help desk, and the idea is we are making these sort of exam profiles, okay? And basically we can custom these internet use, so we can allow maybe necessary websites, or we can block some websites as well. We can allow software or block software. We can allow for USB access for open tests, SEMs, etc. And we can also introduce IP restrictions. So the idea is for this exam profile, there is like this exam portal. In every lab, there is one lecture computer, and we can turn the computers to exam mode, basically. So we have this normal mode, so no restriction, but once it's turned to exam mode, well, students can only attempt their assessments in that mode with the appropriate exam profile that we want. Okay, maybe Dominic's gonna talk about how.
Yeah, so in terms of just how the lab tests rank, so these are the ones that run throughout the term. So these are usually 40 to 45 minutes in duration, and they only run within 1 hour blocks, and usually they're consecutive. So they have to be around about that length so that the invigilators can completely reset the labs for the next session, and like also accommodate for students who are running slightly late. There always are. So each lab test session can accommodate roughly 35 to 40 students, depending on the room. And that's just a limitation based on the number of computers in the room. This setup is more or less consistent across all of our first year courses, definitely. But there are some variations between like some of the second year courses. First year courses usually uniform in terms of what's allowed. It's like we allow some courses to have calculators, for example. There's not. Other courses, especially second or higher, might be more open book, allow students to bring USBs, that sort of thing. Now, in terms of, I guess, how these are actually running in the week, there are all sorts of things that could potentially go wrong. So we need to like constantly introduce countermeasures to try and combat all of these situations. So like students could come to the wrong lab session, right, and result in the session being over full, or individual computers could freeze, in which case do we allow students to like have some extra time on their test and potentially delay everyone to the next session. And one of the big ones is students not being able to log into their computer because multiple reasons. Like usually it's fixed by just having the student reset their password, but sometimes it's deeper. But yeah, and also nice pretty picture with that's sufficiently blurred to protect the names of the innocent. This is week 5 from I believe term 1. Each little column here represents a week of sessions, and as you can see that getting pretty full. Although we leave Monday relatively empty because I'm pretty sure that Monday tests possibly low demand. You can imagine students would prefer to sit their tests later in the week when they've got more time to prepare.
So you can see that, you know, week 5, this is week 5 at the moment. Usually it's the big week. The big week is it's the week where we have lots of these sessions. I think this is, yeah, as mentioned, this is term 1, term 1, and yeah, you can easily see. I think maybe at least 80 sessions easily in that. And then one session is like 40, up to 40 students. So it's a lot of sessions to handle, and this is only 1 week. We have, you know, other weeks as well. And basically for final exams, well, it's like the time frame is shorter. We don't have weeks, maybe, or maybe we have only most 2 weeks mostly. But it's running basically pretty much the same. Only it's longer. So it's basically 2 hours for all first year courses, and we are using all labs basically for in session. So up to 190 students. But the thing is, with large courses such as our first year maths 1A, 1B, 113, 131, where the number of students is easily at least 2,000. At least I think last term that's the case, and there is this need to split these students into many sessions, and then that can take several days. So it's typical for us to have up to 4 sessions. 4 sessions, I think it's the norm a day, and I think that will be, I think that's like 8:30 a.m. Start up to 6 p.m. in a day. Okay, so the preparation to take that into account, maybe as early as 8 a.m. and as late as 6:30 p.m. But we trialed 5 sessions a day last term. So we offered 5th session, so the 6:30 to 8:30 p.m. session, and there's actually demand for that. So quite interesting as well. So with yeah, on those days we have 5 sessions a day, and then starting as early as 8 a.m. Finishing as late as 9 with these sessions. And the turnaround is tight. Yeah, so usually 30 to 45 minutes. If you have, maybe we have 4 sessions, we have 45 minutes to just reset everything, computer from exam mode to normal mode, then back to exam mode, distributing the working papers, making sure that the computers are working, so for students to use. Oh, sorry. Oh, yeah. But if we have more sessions, like 5 sessions, we have to be mindful. The turnaround 30 minutes on those days.
Another thing to mention, just to also point out another pretty picture. This is the story of Math 1A last term. We started with a few exams running on the Tuesday. I believe that the exam was formally scheduled on the Wednesday, which was impossible. Obviously, we can't sit all 2,000 students in our labs on Wednesday. So some was sitting on Tuesday. The bulk of students were supposed to sit on the Wednesday, but obviously that wasn't possible as well. And we also had to have students from other courses sitting their tests, so we had to sort of squeeze them in between sessions. And then like continued on Thursday, Friday, and Saturday, basically all full in our labs. This was actually the time that we trialed those late sessions, and we did find that they were actually quite popular.
Yeah.
Actually more popular than the morning sessions that we have been running all this time. I can't imagine why.
Yeah. So so you can see 5 days easily just for one course. That you have to take into account other courses as well. It gets busy. We we run this basically start to the end with in mind we have 4 to 5 sessions a day. That's like basically the standard. But yeah, so we also want to mention this as well. So with the lab exams, the computerized exams that we've been running, what about those with special needs? So we actually have this unit in UNSW called Equitable Learning Services, or ELS. And the idea is, well, those with special needs, they can get a customized learning plan from ELS. They just need to apply, depending on their situation and conditions. They will be provided with some specialized, customized learning plan. And the special needs might be something like, you know, they require extra time. So maybe an extra 50 minutes per hour, or up to maybe, we've seen like something with like 90 minutes per hour. Students, so that will like basically 150% more than normal students will use. And we also have restrictions on room size. So because our labs downstairs, they can accommodate up to 40, but those with this sort of needs, what some of them might need like a whole room by themselves, individual room, small group rooms up to around 5 in a room, or maybe group up to 15. Some with accessibility conditions, some with on wheelchair, or some who need height adjustable desks. And yeah, we have also some students who require reader or scribe. So the idea is these students, well, we schedule them in a different session. So we separate them. Okay? We separate them and we schedule them manually based on their availability. So we've been doing that for the past weeks, I think. Yeah, the idea is we have this special special room, and I think that the capacity at the moment is 10, 11 or 10, 10, 11. It was smaller, but we've been improving this over and over so that it can accommodate basically more by installing in more computers. Yeah, so we invigilate them separately in this room, and then maybe say on Mobius, if the exam's on Mobius, we can add extra time. We separate them maybe in a different class, or we can just add extra time manually. I think that's it. Yeah. So Nathan will talk about. So this is basically our, the present situation, and there might be some things where we can improve things, and Nathan's gonna be the one who is gonna be talking about that in a second. Right. Thank you.
So, what I'm going to talk about is a little bit of a mixed bag. So Jonathan's kind of given us the history and the foundations, what's gone on, last 30 years, but in particular over the last 5. What we're thinking about is, I guess, we were looking at a bit of an emergency response in some cases, and we're looking at materials and practices that have been part of that emergency response. Over the last 5 years, we've done a really good job of strengthening the foundations, particularly around the logistics that Dominic and Kevin just spoke about. And what I want to talk about as the last little bit of this talk is coming back to some of the content, the exam setting practices, and how we can continue to solidify those practices to, I guess, better suit this format that we've now settled on a really good setup for. Now, I'm focusing on a project for Math 108.1, which is our discrete maths course. It is not as large as our sort of largest term 1A, 1B course. So in term 1, we had just under 1,000 students go through. It does run 3 times per year. The numbers vary. We've got about 500 this term and probably 600 or 700 in term 3 is not unusual. So it's a big-ish course, but it's not massive. So hopefully that makes things a little bit more manageable. What I'm going to talk about are a few specific practices and a few specific changes that we've been working through. Looking back and looking forward, I guess. So first thing is the exam bank. So Jonathan mentioned the exam bank. We collect all of these questions that have been written since 2020, and we give them to students and we say this is going to form an exam. Now, each term, it's roughly the last kind of 2 weeks or so, we give students access to this bank and we say it's going to form a portion of your actual exam. These are your actual exam questions. In Math 108.1, we say 60 to 80%, usually landing on about 40 marks out of 60. So they're getting 40 marks worth of questions that they could have seen before if they'd gone through the bank, and 20 marks worth of new unseen questions. One shift in terminology, which seems quite subtle, but it's something that I already implemented last term, was getting rid of as many references to the word past as possible. Because we did previously refer to these as past exam questions, and students use past exam questions to learn about what to expect in their present exam. And but just by getting rid of, we can sort of, here's a screenshot from the exam bank. No reference to past, although I'll admit right before I took this screenshot, there was a sneaky past sitting up here that I eliminated. But instead of having past exams, we have sample exams. Instead of having a past exam bank, we have an exam question bank. And it's really maybe subtle, maybe it doesn't really matter to students, but from my perspective, at least, it's about keeping these things immediate and relevant for students. These are your questions, or they may be your questions. They will form some of your assessment. They are worth you spending your time on. And what I would like to see, and what I always recommend to students, and I guess just to explain the differences, you can ignore this one for now, but if to explain the differences between the bank and the sample exams, the bank's this big collection of questions. The sample exams are what we would give to students in a 2-hour period. In fact, they're exams that we have given to students in past terms. We just don't want to call them past exams. The idea being they can go through the exam bank at their own pace, question by question, one at a time, take 2 hours on a question if you want. If that helps you sort of learn how to approach these questions, do that. But when you're ready to actually sit an exam, or when you feel like you're ready to actually sit an exam, you've got these curated collections of questions that have balances of difficulty, of topics that add up to 60 marks, things that you can't replicate as easily by yourself if you're a student who doesn't have the experience of setting exams. Now, organizing these things is also a little bit of a nightmare, and I'm just going to refer back to our big courses, our Math 1A, Math 1B courses. There are 350 to 400 questions in the banks for those courses. That's each, right? So you're looking at about 750, 800 questions in total across our 113, 1231, 1141, 124. It's the higher and standard version. In Math 108.1, things are a little bit more manageable with 125 questions at the moment, but it's still a lot of information to organize. It's a lot to expect students to go through, but it's also a lot for us when it comes time to set our exams, when it comes time to decide what's going in each term. And there are two things that I want to think about here, and it's the student side and the staff side. And now Jim Pettigrew, who I believe I saw was joining us online, has set up this really great database for our 1A, 1B courses. I believe he's also done it for our stats course as well. Yes. Yeah. So you can see there's an identifier for the question. There's the course number. Maybe you can't read it if you're in the room. The year, term, the number that the question was in its original exam, and a description, success rate, marks, a shorthand for topics, and any notes that anyone looking at the question might have included. And these two numbers here are also hyperlinks. One of them will take you to the question in Mobius, and the other will give you a screenshot of the question, a kind of fixed version of the question that you can quickly look at if you just want to say, oh, what is this question actually asking? Currently, we don't have one of these outside of spreadsheets for Math 101. Now, we have spreadsheets, we have lots of spreadsheets that record all of this information for Math 108.1, and it's a bit of a mess. So one kind of next step in discrete maths is to implement something like this. And to implement something like this that kind of records all of that information in a central, accessible place. And the other side is for students, looking at what students are seeing. Because when students look at this, I mean, these ones it's not too bad. You go in, you look at your sort of 12 to 15 questions, great. But when you're looking at this top one, you've just got a list of 120 questions. Now, if you've seen one that you really wanted to ask at consultation, you forgot to write down the question number, you're going to have a bit of a frustrating time finding it again. Maybe you didn't take a screenshot, whatever. What I would like to do as part of this project is also create a student-facing database. So it's not going to have information like marks or academic notes or success rate or anything like that. But it will have things like a description of the question, the topic that the question comes from, things like that. And actually, I've been playing around with, I don't know how many universities use Moodle versus Canvas, but for Moodle, there's an excellent database activity that anyone who will listen to me talk about will hear that I'm getting increasingly excited about implementing this because it's very customizable. And you know, you can just import a CSV with all this information, which is great because it's all already in spreadsheets, and we can add or remove whatever pieces of information we want, and suddenly students have this database that is searchable for their questions. And if we attach then the Mobius number question to it, a student can say, okay, well, I want to have a look at another question that asks me about recurrence relations. They can type in recurrence relation, they see all of the questions that ask about recurrence relations. They then go over to Mobius and find the corresponding question, or they look at a screenshot of a fixed version instead of going to Mobius. It's all about creating an experience for students where they can access the information that they feel that they need to help them learn those weak spots for them, right? As well as how we can help them best in our consultations. Another, I guess, looking back, I kind of mentioned some of the questions we're dealing with here are not new, right? They're quite a few years old, and things have changed in the way that we approach writing questions since 2020. A lot has changed, in fact. So the kinds of things that we're looking at, I mean, really simple example, aesthetics, right? The way that we made our questions look in 2020, it's different to the way that we make our questions look now. And when students are in an exam, it's nice to have a uniform aesthetic, right? Now, we often do implement these, we do, not often, we always implement these changes for a question when it goes into an exam, but one part of this project is just doing it for every question up front, so that's not a thing that we have to worry about. Just apply the things, make sure everything is sort of appropriately colored and formatted. Difficulty, now we don't necessarily want or need uniform difficulty, but there are some, I have to admit, there are some outrageous outliers, both on the side of being far too easy and far too difficult in the question bank that we have now. So we can take those questions, and another benefit of not referring to them as past questions is that we can change them, right? If it's part of your exam bank, maybe it's different from what it looked like last term. And it gives us an opportunity to then say, well, we've taken this seed of an idea, this seed of a question that was great when it was originally set, and we've updated it so that it's more in line with the rest of the bank now. In some cases, that might mean cutting out entire parts of questions that are not algorithmic, for example, that have a fixed answer. What's the point in giving a student a question if they can just remember that the answer is 3 and then come back and type in 3 if they see it in their actual exam and not have to think about it? So we can adjust for things like that. Errors as well. You'll see here, this question asks students to give the same answer twice, right? It's algorithmically generated. The equivalence classes of 2 and 2. Now, on one hand, this is great because a student can say, oh, I'm just going to write in the same thing twice. But actually, more often than not, students see that and they think there's a trick in there. They don't think that there's a mistake. They think, oh no, are these different? Is this equivalence class of 2 different to this equivalence class of 2? And it trips them up. So one benefit of going back over those questions and making adjustments is that we can catch these things. And we do often do this sort of term to term, but things slip through. Also, actually, in terms of difficulty, I'll just step back. Here's an example of very easy. Here's an example of very hard. Something that, and I guess the difficulty here is not just in the content of the question, but the amount of reading that a student is going to have to do and the amount of information that they're going to have to pass to be able to answer the question. And it's fine. I'm sure we all agree that not every mark in an exam has to be equivalent to every other mark in terms of difficulty, but there's still a kind of, you know, I guess a distribution of difficulty that we want to operate largely within. Can we ask it better now? So that I've kind of touched on that sort of thing. And essay boxes. So a lot of our questions are algorithmically marked. They're algorithmically generated. They're algorithmically marked. And we do have markers looking over every exam to make sure that common errors are caught, both common student errors and common algorithm errors. But we do have essay boxes in there as well that are manually marked. And one thing that I'm looking at as I'm going through this bank of questions is, are the essay boxes that we're using asking the best things that they could be asking? So there was a big tendency early on to ask a student to give an answer that's algorithmically marked and then add an essay box to say, explain your answer. Can we ask for something a little bit more specific than that? Is that the most appropriate thing to ask here? In some cases, it's not. In some cases, it is. And it's just about taking a bit of a critical eye to what we have in the questions at the moment. But also, when we're setting questions in an exam, when we're deciding what's going in this term, the number of essay boxes is something that we look at because we don't want students to have just algorithmically graded answers, but we also don't want them to have so many essay boxes that they can't possibly respond to them all in the time that they're allocated. So it's important that the ones that are in there are the ones that we really want in there, I suppose. Measures of difficulty. So this is something else that we think of when we're looking at what questions go in. And there are two things that we can look at. One is what we think is difficult. And part of this process, as I've been going through, I've been just putting a little marker on problems, a difficulty, you know, Nathan's judgment of how difficult this problem is as an integer between 1 and 5. It's not universal, but at least it's consistent across everything. And success rates. So you did see in Jim's database there was success rates included. And I'm guilty, and I'm not going to point fingers at anyone else because I don't know who else does this, but I'm sure others do as well, of not looking at success rates kind of in a sensible way. What I mean by that is often when I'm looking at the success rates of a question, so what Mobius says students, what percentage of a grade students received, I'll look at the first time a question was used, which is when it was an unseen question. And that's not going to be a reflection of how difficult students are going to find this question when they've seen it before. So going back and having a look at some past success rates rather than just having a single term, just connecting some multiple attempts, I guess, multiple cohorts attempts. So there are so many factors that can change how students perform, and that could be, you know, things like where in the exam does this question sit? Is it at the beginning? Is it at the end? Was this question in an exam that a student sat yesterday, and could that student have told another student about it and therefore inflated a particular success rate? Things like that. So neither of these things are perfect, but they're kind of the best we have in terms of gauging how difficult questions are. And it is important that we do look at how difficult questions are because it's data that we have that we don't necessarily have with pen and paper exams when we're writing a pen and paper question that is kind of unique and we can say, well, we know students tend to do well with this or tend to do poorly with this, but there's concrete data here that we can work with. So just keeping that in mind. Writing new questions. So there are 20 in 1081, about 20 marks per term or per exam that questions that students haven't seen before. Now, this is tricky and it's become increasingly tricky as the exam bank has gotten bigger because you want to ask new questions, right? I don't need to ask students to solve a second order homogeneous recurrence relation. It's already in the bank. If I want to give them that question, I'll give them that question that someone else has coded for me already. That means that we have to be creative in the questions that we're asking, and it's led to some trends that some are good, some are bad, or some are less good, I suppose. One of which are these kinds of narrativized questions that require a lot of parsing and a lot of understanding, not just of mathematical ideas, but also of language, right? Just having a really good grasp of what a sentence means. And that is not the strength of every student, and that's not necessarily a reflection of their mathematical abilities. And reviewing the bank, something that I've realized as I've been going through the questions is actually I've been able to identify some gaps in the course where maybe there's only a small number of questions that assess this particular sort of subtopic or idea. And maybe those questions are old or they're very, very easy. So there are opportunities to them. So by reviewing all of the questions we've got in this bank, there are great opportunities there to resolve that problem we come to towards the middle to end of every term, where we say, okay, what new question can I come up with this term? Because it does tend to be a bit of a headache, and we also tend to fall back on, enumeration is a great topic to write new questions for, because you can always come up with the same enumeration problem with a different label on it, right? Also planning, so this is what I've sent through to the other lecturer for the course this term as a tentative plan for what I think our questions should look like. And to give you some sort of context on what's going on there, the idea is there will be 4 sessions. We're planning to have 4 sessions. They need to be different in some way. Each session will have one unique 6-mark question. Hopefully there are no students loitering outside that are listening to this. Each session will have one unique 6-mark question written just for that session. Then each session will have a shared question worth 4 marks with each other session. So session 1 will share something with 2, with 3, with 4, worth 4 marks. And then one 2-mark question that all 4 sessions will see. So it gives us, again, data points for comparing how students in different sessions are going, which is really useful for us when we have all of this information about how students have performed each term and have to decide how do we assess session 1 against session 4 when they sat the exam 3 days later, or so it's just about giving some common data points there and planning carefully. You'll also notice that this is a bit more flexible, the number of essay boxes, but again, it's something we want to control for. Keeping it in the individual session questions is not necessary, but having the extra marks there to play with makes sense. But I certainly wouldn't be opposed to someone saying, well, actually, I want to put a couple of essay boxes in here and instead of up here somewhere, and then we just say, okay, well, what does that mean for the rest of the planning? But the key here is planning, and also we get to see how many new questions we're going to be introducing into the bank for next term. The last point I'll make there is A and B. So 5, 6, and 7 all have an A and B, and this is designed to reduce the amount of work that goes into coming up with new questions. They would essentially be 2 questions, 2 different questions with a shared base. So to give you an example, an A and B that we used last term, we had a recurrence relation problem for both pairs of sessions. In one case, we were talking about an artist tiling a mosaic. In the other case, we were talking about an AI-generated picture working pixel by pixel, where in both cases, the next pixel or tile was determined by the color of the previous. And so we were then able to ask slightly different questions, but essentially asking students to understand how this particular process could be understood as a recurrence relation and communicated that way. So 2 different questions, but assessing the same ideas. And it just reduces a bit of sort of question writing labor. And lastly, I want to wrap up on helping students to prepare. So the exam question bank is a way of helping students to prepare in its own right. And Jonathan spoke really clearly about why, the motivation for doing that sort of thing. there are a couple of changes. So in Math 1081, students see exam question bank problems in their tutorials. There's one per week. There's an example of that here. So they get their tutorial sheet, they work on boards around the room, and there's a little flag on it that says this problem's based on a question from the exam question bank. It's not exactly the same. It's sort of opened up a little bit so that you know the Mobius specific parts of the question are removed, but essentially the exercise is the same. It's taken exactly from the bank. So we're getting students seeing those questions, exposed to those questions from the beginning of the course, even if they look at it and think, well, I don't know how to do this. That's fine. It's part of that process of making them feel more comfortable with not knowing. And then as the term goes on, our hope, at least, is that they become more comfortable with these questions, and then the exam bank itself is released, and there is a degree of familiarity there with the level of detail or understanding that we're requiring of them. And we're also recording some video solutions as part of, actually, this project started as is sort of nominally an edutech project that's designed to sell our upgraded Merlin studio. So we have all three of these videos were recorded in the same room using the same computer. We have a whiteboard, a light board, and a green screen setup that academics can use. And we're going to be recording some video solutions to a portion of these exam bank problems that will then be incorporated into this student-facing database. And they'll also use some H5P. I recorded a little sample of how this works this morning, a little 5-minute video of how one might do this. It'll be great for anyone who has those moments, maybe when recording a video, where they ask a rhetorical question and pause for a few seconds while students think and then answer it, because H5P allows you to ask that question explicitly. So it's about, again, helping them to prepare, making this idea of having a bank of questions that's 125 or 350, 400 questions large feel more approachable, but also coaching them more explicitly in how to think about the problems. Not just, here's an answer, but how can you approach this if you don't know how to approach it? And we have 9 or 10, if you include me, 10 academics involved in recording these solutions. They'll do a few each. An extra benefit, right? As mostly first-year students, becoming familiar with the different staff of the school. Maybe they'll see someone that they'd really like to be taught by down the line. They'll look up what course that person's teaching, and we might get some people doing courses they might not otherwise get, or connecting with staff that they might not otherwise connect with. So that's pretty much it. This is a big undertaking. There are lots of pieces to this project, but ultimately the goal is, how can we take this foundation that has some really, really strong elements, but also takes us back to COVID response time and solidify it all, create something that's of a greater standard and can also help us to help our students moving forward to learn the things that we want them to learn. That's it. Thank you.